to everyone. I welcome you in my YouTube video channel. Today, I will deliver lecture on trigonometry degree level, chapter Deductions from Moivre's Theorem, lecture number 1, in which I will expand the sine n theta and cos n theta. Before coming to the main part, I would like to give you some basics which will help to understand the main part. First basic is formula for NCR combination, and formula for this is NCR equal to factorial n by factorial r multiply factorial n minus r, where factorial n means 1 multiply 2 multiply 3 multiply multiply n. Example, 5c2. Here 5 is in place of n and 2 is in place of r. So this is factorial 5 by factorial 2 multiply factorial 5 minus 2. Here factorial 5 means 1 multiply 2 multiply 3 multiply 4 multiply 5. Factorial 2 means 1 multiply 2. Factorial 3 here is 1 multiply 2 multiply 3. So up to 3 cancels here. Only remains 4 and 5 by 2 is 10. Second basic is binomial theorem for positive integral index. This is a plus x whole to the power n equal to nc0 a to the power n plus nc1 a to the power n minus 1 x to the power 1 plus nc2 a to the power n minus 2 x square plus nc3 a to the power n minus 3 x cube plus and lastly ncn x to the power n. Now we apply these basics to prove the main part. Now I will start to expand sine n theta and cos n theta where n is a positive integer. Since by de Moivre's theorem we know that cos theta plus I sin theta whole to the power n equal to cos n theta plus I sin n theta, where n is a positive integer. Implies that cos n theta plus I sin n theta equal to, we expand this with the help of binomial theorem. So this will be equal to nc0 cos theta to the power n plus nc1 cos theta whole to the power n minus 1. Second term I sin theta plus nc2 cos theta to the power n minus 2 I sin theta square plus nc3 cos theta whole to the power n minus 3 I sin theta whole cube plus nc4 cos theta whole to the power n minus 4 I sin theta whole to the power 4 plus nc5 cos theta to the power n minus 5 I sin theta whole to the power 5 plus dot 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 plus ncn I sin theta whole to the power n. This equal to nc0 means 1, then cos to the power n theta plus nc1 cos to the power n minus 1 theta I sin theta plus here I square is minus 1 minus nc2 cos to the power n minus 2 theta sin square theta. Here I cube means minus I nc3 cos to the power n minus 3 theta sin cube theta. Here I to the power 4 is 1, so this is plus nc4 cos to the power n minus 4 theta sin to the power 4 theta plus here we see I to the power 5 means I, and here nc5 I nc5 cos n minus 5 theta sin to the power 5 theta plus dot 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 plus last term but 1 means one term before the last term is I to the power n minus 1 nc n minus 1, that is nc1. This value is equal to nc1 and cos to the power n minus 1, that is cos theta sin to the power n minus 1 theta plus I to the power n ncn means 1, and we get here sin to the power n theta. Let this is number 2, equating real and imaginary part. Of both sides we get real part of left side is cos n theta equal to, in right side this is real part cos to the power n theta, this is real part minus nc2 cos to the power n minus 2 theta sin square theta, this is real part plus nc4 cos to the power n minus 4 theta sin to the power 4 theta plus dot 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 to finite number of terms. This is number 3. And imaginary part. Left side is sin n theta. Sin n theta equal to, in right side imaginary part is this, nc1 cos to the power n minus 1 theta sin theta. This is imaginary part, minus nc3 cos to the power n minus 3 theta sin cube theta. This is imaginary part, plus nc5 cos to the power n minus 5 theta sin to the power 5 theta plus dot 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 to finite number of terms. This is number 4. Now we will find the last terms of 3 and 4, which depend on the condition that n is an even number or odd number. When n is an even number, then the last term of is I sin theta whole to the power n. This is equal to I to the power n sin to the power n theta. N is even, then we may write this I square to the power n by 2 sin to the power n theta. I square is minus 1 to the power n by 2 sin to the power n theta, which is free from I. This is number 5. So this value will be last term of real part, that is cos n theta, of expansion of cos n theta. Therefore, for n is an even number, cos n theta equal to cos to the power n theta minus nc2 cos to the power n minus 2 theta sin square theta plus nc4 cos to the power n minus 4 theta sin to the power 4 theta plus dot 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 dot, and lastly minus 1 to the power n by 2 sine to the power n theta. This is number 6. Again, when n is an even number, then the last but one term of 2 will be last but one term means one term before the last term, and that will be n minus 1 cos to the power n minus 1 theta I sin theta whole to the power n minus 1, and this is n and this is cos theta. Here I to the power n minus 1 sin theta to the power n minus 1. This equal to n cos theta. We write this as I multiply I to the power n minus 2, I to the power 1 and I to the power n minus 2 is n minus 1, and here sine to the power n minus 1 theta. Since n is even, implies that n minus 2 is even, and this will be equal to n cos theta. Here I, we write here I, and this will be I square to the power n minus 2 by 2 sine to the power n minus 1 theta, and this will be equal to I n cos theta. This is minus 1 to the power n minus 2 by 2 sine to the power n minus 1 theta. Therefore, this term is imaginary term. Let this is number 7, which is imaginary. Therefore, this term will be the last term of sine n theta. Therefore, sine n theta equal to nc1 cos to the power n minus 1 theta sine theta minus nc3 cos to the power n minus 3 theta sine cube theta plus nc5 cos to the power n minus 5 theta sine to the power 5 theta plus dot 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 dot, and last term is minus 1 to the power n minus 2 by 2 n cos theta multiply sine to the power n minus 1 theta, and this is number 8. When n is odd, then the last term of 2 will be I sin theta to the power n, and this will be equal to I to the power n sin to the power n theta. Since n is odd, so we try to make it even. That is, I multiply I to the power n minus 1 sin to the power n theta. Since n is odd, implies that n minus 1 is even, and this will be equal to I. We write this I to the power 2 and here to the power n minus 1 by 2 sin to the power n theta. This will be equal to I square means minus 1 n minus 1 by 2 sin to the power n theta, which is imaginary. So this term will be last term of sin n theta. Therefore, when n is odd, then sin n theta equal to nc1 cos to the power n minus 1 theta sin theta minus nc3 cos to the power n minus 1 cos to the power n minus 3 theta sin cube theta plus nc5 cos to the power n minus 5 theta sin to the power 5 theta plus dot dot dot, and last term will be minus 1 to the power n minus 1 by 2 sin to the power n theta, and this will be 9. Now, when n is odd, then last but one term equal to nc n minus 1 cos to the power n minus 1 theta I sin theta to the power n minus 1, and this is equal to nc n minus 1, and this is equal to cos theta multiply I to the power n minus 1 sin to the power n minus 1 theta. This is equal to n cos theta. Since n minus 1 is even, so we may write I square to the power n minus 1 by 2 sin to the power n minus 1 theta, and this will be equal to minus I square means minus 1 to the power n minus 1 by 2 n cos theta sin to the power n minus 1 theta, which is real. and for this reason this term will be the last term of cos n theta. Therefore, when n is odd, then cos n theta equal to cos to the power n theta minus nc2 cos to the power n minus 2 theta sin square theta plus nc4 cos to the power n minus 4 theta sin to the power 4 theta plus plus last term is minus 1 to the power n minus 1 by 2 multiply n cos theta sin to the power n minus 1 theta. Let this is number 10. From 6, 8, 9 and 10 we write the expansions of cos n theta and sin n theta in two different cases. For n to be an even number and for n to be an odd number. When n is even, then cos n theta equal to cos to the power n theta minus nc2 cos to the power n minus 2 theta sin square theta plus nc4 cos to the power n minus 4 theta sin to the power 4 theta plus with last term minus 1 to the power n by 2 sin to the power n theta. And sin n theta will be, when n is even, this equal to nc1 cos to the power n minus 1 theta sin theta minus nc3 cos to the power n minus 3 theta sin cube theta plus nc5 cos to the power n minus 5 theta sin to the power 5 theta minus the last term is minus 1 to the power n minus 2 by 2 n cos theta sin to the power n minus 1 theta. Similarly, when n is odd, then expansion of cos n theta is same up to this term, but last term is different. Last term is minus 1 to the power n minus 1 by 2 n cos theta sin to the power n minus 1 theta. Here sin n theta, this is also same as up to this, for n is an even, but last term is different. Here last term is minus 1 to the power n minus 1 by 2 sin to the power n theta. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.